Okay, hello everyone. I'm Ziheng Xu from Group 27 of ENG6. I'm in first year mechanical engineering major, and I'm glad to show everyone about our project.
Hi everyone, I'm Ting Chen Yuan. I'm second year computer science major.
Hi everyone, this is Yu Tong from Group 27. I'm majoring in applied math.
So what we're showing here is our core component. Right here, it's showing us about the points. Because of the time limitation, we just have preset some data to the ThinkSpeak. You can see here, there's a bunch of data in the ThinkSpeak. And back to the things, what we have here, because we have the historical additional features, we can see the point that is the ship's previous point. And you can obviously see that the point between the red cross is actually increasing. This is distance is increasing, which means we have a variable speed function. And the yellow point is doing a round trip between these 1 and 2 and 3 points. So we have our round trip function. And I will go, so Ting-Chen, you can go to the next.
Okay, let me control the screen. Yeah, so I'll talk about the basic features of the core component and some of the additional features. So here, as we can see that we can choose the on and off for each vessel. And if I have put that into off, we can see the red one will disappear in a few seconds. And we can use those functions to decide which ship we want to show on the map. And with the speed learn function, we can have we can set the limit speed, and whenever the vessel reaches the limit speed, the alarm will automatically be changed to red. And if we have the reset speed alarm and we press that button, it will change back to green. And we can wait a few seconds to see if that works. So the speed is like increasing. So yeah, you can see that the speed alarm turns to red, and we use the reset to have it back to green. And here's the filter we have, and we can use that to filter the ship with their width and length. And we can first try to have it to be 5. We can have it to be 5, and you can see after the filter, all the ship have the width like larger than 5. And if we try to have it to be 25, and you can see that all of them are like the width is not reached 25, so it just automatically turned off. And for the length, it's like basically working the similar way as the width filter. So we can try to have it to be 75, and we can change this back to 0, and we can filter the length to be filtered. So in that case, you can see one of the ship was turned off since it's shorter than 75, and if we have it lower than 75, you can see only one of that become turned on since it's shorter than 75. Yeah, and Ziheng has already introduced the historical location point function, and we can use on and off for this one to decide whether or not to show the historical point. Yeah, that's it. Let's welcome Yu Tong to introduce the rest of the additional function.
Hi, so please allow me to introduce our collision alarms and position alarm. I'm gonna remote control the screen. So we already preset the value for the collision alarm, which means that if the distance between two ships has already reached that value, then the collision alarm will be activated. So we also have a customizable button for our customers, which is the limit distance. Now let's change the value of the limit distance. Let's see 10, which is pretty large. And let's click on. Then we will see that the button for the collision alarm has already turned red, which means that two ships will activated the collision alarm. So let's reset the collision alarm and see the position. So we can see that this button has turned red because the position of some ship has already been over our boundary value. So this lamp will go red to remind people. Now let's go to the code part.
Okay. About the code part, we are gonna start with our core component. You see, start everything here. When you click the start tracking button. Okay, first is the setup function. We just generally set some buttons. Basic is on or off in the UI. And what we have here is a simple timer. This one is for the test function. It will just show the running time right here, and the time will just increase for increase 1 second for each 1 second, and everything start here. So basically, till here to there, the O function of this part will just extract 3 MMSI from the ThinkSpeak table or the local table. So it will recognize which 3 MMSI we are going to use. If there's more than 3 MMSI, we just use the most recent 3. And there will be a function, which is still a timer, that is called the scatter function for each 3 seconds. And the Tinchan, you can keep going with the function right here.
Sorry, you are muted.
Yeah. Sorry, I'm just trying to. So here is our scatter function, which is our main function. I'll use vessel 1 to as an example, since like the 3 vessel has the basically very similar logic. So here we can see that the on button value to be true, which means that we have the ship 1 to be in the on mode, which means we can see the current location in the map of that ship. And we use the geoplot since we use the geo axis in the panel to display a section of the map. And here's our limit speed value. If like whenever the ship reaches the limit, the lamp will be turned to red. And another thing is about the filter, which we can see in this part. So we can see in this part, we use the filter function, a bunch of if-else statement to decide the decision of the user to be the width to be higher or lower and the length to be higher or lower. And we can filter that with this bunch of code. And back to the scatter function, we also have the collision and boundary position alarm, and let Yutong introduce this part.
Hi, let's see the code for the collision alarm and position alarm. So first of all, let's see line 158 and 159. By extracting the data from the table, we can find the latitude and longitude for our first ship. And then we use the if statement to find if the latitude for our first ship is less than 30 or greater than 50, and the longitude for our first ship is less than 180 or greater than 220, then as I shown before, our position alarm lamp will turn red. And this should be similar for our ship 2 and ship 3. That's the same function. And then let's see the code for the collision alarm. So we use the formula about distance between 2 points. to find the distance between two ships. Now let's see line 249. We find the distance between ship 1 and ship 2, ship 1 and ship 3, ship 2 and ship 3. And then we set the limit distance as a value. Then we check if the distance between ship 1 and ship 2 is less than that value, and also the similar for our two other ships. So if the distance has already been over that value, our lamp will go red, just as what I shown before. Now let's go to Ziheng.
Okay, so we are going to back to the reach components, and here is our reach components. It's quite complicated, but I will just explain it quickly. So everything start here. It's just ship 1 simulation button, which is this button, and we're gonna store all the value you have input into a table and set it to a general table. And what we have here is if the round trip button is on, then it will go into another special situation, which is it will just set some special value for it. And still, okay, and right here, it will be just some default settings for the UI, and still a timer to count for every ship 1 report interval, which means for each, when the time passes for the report interval time, then it will call the function of the ship 1 ThinkSpeak write. So this one will be kind of simple logic. We just extract the data from the table and use a function to calculate the speed, the change in latitude and change in longitude, and we just input them into the data. So this switch function is designed for the round trip, because the round trip logic is they have 3 index for it. First one is start, which means it's move from the start to the midpoint. The mid means it's from mid to the end point, and the end means the end to the start point. It's just a round trip. And for each one, they will just input different kinds of data to calculate the speed and the position. If the round trip is not on, you just simply calculate the start, the speed and position between the start and end point, and it will go here as the y and length, because they're basically same every time. And when everything's finished, they will store this data into the O ship data table. And that one will be called when we are trying to upload the data to the ThinkSpeak. So we just output the O ship data into this data, and this will be the size, which means how many rows we have in this O ship data table. And we'll have an upload index, which is started from 1. If the uploaded index is lower than the data size, which means we haven't uploaded all the data we need to the ThinkSpeak, it will create an for loop, which is just upload 1 by 1 from the index +1, which is the next one we need to upload, to the data site. The data set will keep increasing when the report for each ship is recorded, like their position is recorded and need to wait for the upload. And it will just ThinkSpeak right to the channel. And we actually have 8 fields for them. Each of them are representing special properties for the ship. And for each one, the last upload index will be changed to the maximum size of this table. And that's all for the reach component. Basically, this function will be just the function that is calculating the changing coordinate. It will output change LA, and speed. For every time you do the calculation part, we will call this function. And I think that's all for our project.
Thank you so much
thank
for
you.
watching.
Yeah.
Thank you.
So we're gonna do a separate demo for the reach component because it will take too many times. Because it uploaded to the ThinkSpeak, but it requires it to wait for a while. Then the read function in the core components will exactly read the data from the ThinkSpeak. So right here, we have, I just input some data and the ship one, the round trip is on. And you can see the speed is actually a function, depends on the time. So you can, if you just set 3 on the third space, and you just get a constant speed. And if you set other things, you will have a variable speed. So we start uploading right now, and you can see back here is the ThinkSpeak channel, and you can see it is uploading the data and it just keep updating. Right now, I will just cut the part that is keep running. Okay, so we are at the middle part of it. I will show this function about the stop transmission. This will cause the transmission stop, but the ship will keep simulating and it will keep moving. As you can see, the ThinkSpeak right now doesn't receive any data. It is not updating now. But if I click the on again, we'll keep receiving the data. And you can see there's a kind of like a very blank, which means in this time, during this time, it doesn't receive any data. But the simulation is still keep working inside the reach component. Okay, we are back here. I will stop the transmission right now. And we can see there's a bunch of data in the ThinkSpeak, which means we should have a pretty good look in the core components if I grab this point out, and I would do that right now. So what we have here is the point. Yeah, I mean, yeah. So because I have a relatively high speed for the one of the ship, it just move 4 points, and that's all. And okay, we can see here. Well, this one is. I'm pretty sure this kind of space is because I stopped the transmission for a while, but the core component just skip that. Yeah, we can see the yellow point is actually doing a round trip in this kind of direction loops. And so that is all I need to show for the core for the reach components. And yeah, oh yeah, by the way, there's a increase in speed for the green point and also for the yellow point, because we have a variable speed function, variable speed for it. And that's all.